All right, so today we're taking derivatives using the product rule and quotient rule. You can see them here, right? We've got the product rule right there where we are taking the derivative of two functions that are being multiplied. And we do that by taking the first function times the derivative of the second plus the second function times the derivative of the first. And then the quotient rule, we have a quotient of two functions, assuming the denominator is not zero. We have the bottom function times the derivative of the top minus the top function times the derivative of the bottom all over the bottom squared. So in conjunction with these two rules, we're going to be using our derivatives from previous sections. So let's just quickly review some of those that we're going to be using today. So the derivative with respect to x to the n, right? Our power rule is this. And we also had the derivative with respect to x of an exponential function, e to the x, or the exponential function, the natural exponential. We get e to the x. And then we also have the constant multiple rule, right, where we're allowed to take the constant c that's multiplying f of x and pull that out and just take the derivative of f like that. And then we also had the sum and difference rules, which looked something like this. If you're adding or subtracting the two functions, you can just take the derivative of each one separately, like this. And the same thing if you have, I'll just do it in a different color. If we had a minus sign there, we'd have a minus sign there. So those are pretty much the rules that we're going to be using. If something else comes up, I'll add to this list. But let's go ahead and just use our product and quotient rules as they come up and see where it takes us. So the first one, we want to find f prime of x. So we have f prime of x is going to be, we have a product of this function and this function. And yes, we could distribute and simply use the rules from earlier, but we want to practice the product rule. So here we go. The first function times the derivative of the second function plus the second function times the derivative of the first function. Now I haven't actually taken any derivatives, I've just written out the product rule, okay? And you can see it, first function here, right? Derivative of the second function there, second function there, and then the derivative of the first function right there. So anyway, that's the idea. And now we'll actually take some derivatives. So we have negative 5x to the third. The derivative of 2x squared minus 1 is going to be 4x using the power rule, plus 2x squared minus 1, taking the derivative of negative 5x to the third will give us a negative 15x squared using the power rule. And we should simplify this. This becomes negative 20x to the fourth, plus distributing the negative, or distributing this guy right here, we're actually going to get a negative 30x to the fourth, and multiplying here, we're going to get a positive 15x squared. Combining like terms, we have negative 50x to the fourth plus 15x squared. And there it is. All right, part B. Again, we're going to use product rule here. We have g prime of y. We have our first function. Now, keep in mind, we could just take this 2 out and make it a constant multiple, or we can make it part of one of the functions, right? I personally would prefer just take the 2 out because it's easier, but most students would think, okay, well, I've got my, here, let's highlight it. I've got my first function in blue like this, and my second function in green. So that's usually how a student would think about it, and from what I've seen over the years. But whatever, let's just see what happens. So if we take our first function times the derivative of e to the y is just e to the y, but I'll go ahead and write this. Whoops, it's a dy. We're taking the derivative with respect to y here. And then, so there's the first times the derivative of the second plus the second times the derivative with respect to y of 2y to the fourth. And I'm going to ditch the colors here now, and we've got what? 2y to the fourth, derivative of e to the something is e to the same thing, right? Plus e to the y, and then taking the derivative of blue and back there, we're going to get times 8y to the third. You'll notice you could factor out an e to the y, which, I don't know, maybe it looks a little bit better this way. 2y to the fourth plus 8y to the third. And actually, many of you are probably thinking, hey, we can also take a y to the third out. So I'll go ahead and do that, and I get 2y plus, I can also take a 2 out. Oh, I gotta pay attention to what I'm doing here. So we can take a 2 out, a y to the third, and e to the y, right? So we're left with y plus 4. I think that works. And there it is. Okay, so those are two product rule problems. Let's go ahead and do some quotient rule on these next two. And I'm probably going to write a little bit smaller because quotient rule takes a little more work. Let's see here. So we want y prime, which is going to be, we're going to be using our quotient rule, which is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Some people memorize it with low d high, less high d low, draw a line and square down low or something like that. But here we go. So we have, whoops. We have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And again, I haven't, just like I did in the first two examples, I haven't taken any derivatives yet. I've just written out the quotient rule. And some of you might be thinking, do I really need to write that step? You could probably get away, well, you can get away with it, let's put it that way. For now, I just want to be really clear on what we're doing step by step. Later on, once we get really comfortable with the quotient rule, I'll just go ahead and take derivatives and do the quotient rule simultaneously. For those of you who might not see what I'm saying is, I could have taken this derivative in my head and not written it as d dx of x to the third, right? I could have just written 3x squared. And the same thing with this. I didn't need to write this in yellow. I could have just written 8x to the third minus 1. And we will get there where we do it that way. Before we continue, let's pause for a moment and notice something. We could continue with this quotient rule, and it'll work, and it'll get us a result, but I want you to look at the original function first. Is there something we can do to the original function to maybe make our lives a little bit easier? What I'm hoping you're seeing is that you can factor out an x on the bottom and an x on top and cancel, right? So you have x times x squared on top, and you have x times 2x to the third minus 1 on the bottom. And then these guys cancel, and then we have a simpler function that we're going to be taking the quotient rule of. So I'm going to change my quotient rule now, and so we can take the derivative of this version of our function. Okay, it would have worked the other way as well. It's just that we would have ended up with a result that we would need to simplify. But anyway, so I'm going to change this, whoops, I lost my fraction bar there. I'm going to change this first function to 2x to the third minus 1. My second function becomes x squared now, like this. And my bottom function, I guess I should say my top function, becomes x squared. And then my bottom function is 2x to the third minus 1. And of course down here we're going to have 2x to the third minus 1 squared. All right, so moving forward, we're going to take our derivatives. Here we have a 2x minus x squared. In back, we're going to have a 6x squared, right? That's the derivative of this guy right here, I believe. And that should have been a bracket back there. And then what do we have? On the bottom, we have 2x to the third minus 1 squared. Resist the urge. you are not allowed to cancel these. Okay? Resist it. Because this right here is a product that's involved with a term. Okay, the only way you can cancel off a 2x to the third minus 1 on top and bottom is if the whole top were being multiplied by that factor right there, and it's not. It's one of the most common errors, algebra errors that come up in calculus. So we're going to distribute the 2x. We're going to get 4x to the fourth minus 2x minus 6x to the fourth all over 2x to the third minus 1 quantity squared. That's going to give us what? A negative 2x to the fourth minus a 2x all over 2x to the third minus 1 squared. I'll go ahead and factor out a negative 2x. I actually would accept the answer right here. We're going to talk more about what format to put answers in, more so in the next chapter, because we're going to use these derivatives to do certain things. And some of you may be noticing that in the numerator now we have a difference of cubes that can also be factored, but I'm going to leave it for today. As we'll see again in a future chapter, we'll find situations where we're going to want to take that further. All right, onward to part D, another quotient rule, this time involving e to the x. So we're going to have q prime of x. Always label the fact that you are now writing your derivative, right? Kind of like I did back here. This was all the function y, and it's clearly labeled as such, and all of this is our function y prime, the derivative, and it's clearly labeled as such. So here we go. We're going to take the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And taking the derivative of 9e to the x is simply 9e to the x. And taking the derivative of that function in the numerator in the back is just going to be plain e to the x, right? Over e to the x plus 1 quantity squared. I'll distribute this 9e to the x here. I'm going to get 9. Remember, e to the x, when I multiply it times another e to the x, I'm adding the exponents. So I'm getting e to the 2x. And then plus 9e to the x. And over here, again, we're adding exponents. When we multiply same bases, we get minus 9e to the 2x. And on the bottom, we have e to the x plus 1 quantity squared. Of course, these guys subtract to 0. And we have our derivative function is 9e to the x over e to the x plus 1 quantity squared. Like that. So there's that one. All right, so we've got two more of these before we kind of shift gears and do something a little different. What do you notice is going on here? Well, my guess with both E and F, you're immediately noticing that you have quotients, right? You have a numerator, you have a denominator, you have a division problem, and you're going to have to use a quotient rule. But both of them also have something else. Right here, we're multiplying, aren't we? Right there, we're multiplying. So we have to use the quotient rule and product rule. Oh, that sounds like fun. Let's get to it. So what do we have? We've got y prime is equal to the bottom function times the derivative of the top function, which will require a product rule in there. Whoops, let's make that clean and clear. Okay, so there we go. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so this is a perfect example of why I like to write out the quotient rule without actually taking any of the derivatives, right? Because this derivative here is going to be a little bit of work because it's going to require a product a product rule. And some of you are thinking, well, why don't we just distribute the e to the x? Maybe we can avoid the product rule. I love that idea, but when you multiply here, you're going to get x e to the x. And when you take that derivative, you're good, right? And then you get e to the x here. But when you take this derivative, you're still going to need to use the product rule. So you're not escaping it. It's not going to happen. So anyway, doing that part in yellow, I'll actually do it in yellow just for fun. We have what? The first function times the derivative of the second, derivative of e to the x is e to the x, plus the second function times the derivative of the first function, which the derivative of x plus 1 is just 1, so that's times 1. And all of that is going to be multiplying the x plus 2 there. And then we can copy everything else in black. Oh, of course, here, the derivative, and for some reason my little d dx got kind of messed up there, but the derivative of x minus 1 is just x minus 2, I should say. The derivative of x minus 2 here is just 1. So if you want, you can write it times 1, but it's really unnecessary. And then on the bottom, we have x minus 2 quantity squared. Now, I'm noticing, oh my goodness, I'm noticing I have a mistake here. It's an x minus 2. This should be a minus here. This should be a minus there. Okay, so I got lucky. I know as you're watching this, you noticed that a while ago, but at least I figured it out, right? Okay, so now we just need to simplify this silliness. So what do we get? We've got x minus 2. Distributing here, I'm going to have x e to the x plus e to the x. And then this right here is another plus e to the x. Minus, this is an e to the x that I can distribute into here, right? But I'm also distributing a negative in there, right? So I'm distributing from both sides. So you can just think of it as distributing a negative e to the x, right? You're distributing this into here. And that's going to give me a negative e to the, or let me write it this way, negative x e to the x minus e to the x all over x minus 2 quantity squared. Okay, tons of fun with algebra here, yeah? Okay. Now, I can multiply these guys out. It's going to be 6 multiplications. So here we go. Distributing the x, there, there, there. Looks something like this. Oh, wait a second. We can add these guys. Shouldn't make these videos when I'm so tired, huh? Anyway, I can add those, right? E to the x plus e to the x gives me 2e to the x. So I'm just going to go ahead and do that right now in this step. I'll do it in purple so it stands out, and then that way we have two less multiplications that we need to do. So I'm just going to write plus 2e to the x there. All right, so now distributing, we're going to get x squared e to the x plus 2x e to the x when we multiply the x over here. Now we're going to multiply the negative 2x e to the x, and then distributing the negative 2 to the purple, we get negative 4 e to the x. I have a minus x e to the x minus e to the x, and all that over x minus 2 quantity squared. Now we do have some things that cancel. This guy and that guy. And that looks like it. So we're going to have a final result of x squared e to the x minus, well, we can combine these guys in green. Negative 4 e to the x minus an e to the x will give me a negative 5 e to the x minus x e to the x all over x minus 2 squared. You could factor out an e to the x and write x squared minus x minus 5, which does not factor for us. Would have been cool if it did, but didn't. So there it is. Okay, thank you for bearing with me through a couple of errors and not noticing a couple things, but I think we finally got there. All right, we get to do the same sort of thing again. This time we have a product in the denominator. we've got h prime of x is equal to the bottom times the derivative of the top. Should we just take the derivative of the top? What's the derivative of the top? 3. Okay, so there's low d high, right? We have the bottom times the derivative of the top minus the top times the derivative of the bottom. And that one is going to require product rule. And all of that over the bottom squared. Excellent. So we've got 3x to the third e to the x minus 3x, oh, careful, minus parentheses 3x minus 2. And now over here in green, we need to take this derivative. So we're going to have times the first times the derivative of the second, derivative of e to the x is e to the x, plus the second times the derivative of the first, which is 3x squared. All of that over, I'll just go ahead and square this, x to the 6th e to the 2x, like that. And now we're going to distribute green and, right, we're going to distribute these guys right here and then combine like terms and we'll be done. So we have 3x to the third e to the x minus multiplying our 3x here. I'm going to have 3x to the fourth e to the x. Multiplying it there, I'm going to have plus 9x to the third e to the x. Multiplying the negative 2, we're going to have minus 2x to the third e to the x. Finally, back here, we're going to have minus 6x squared e to the x. All over x to the 6th e to the 2x. All right, distributing that negative, we're going to get the same thing, but a whole bunch of changing signs in the parentheses over there. All of that, x to the 6th, e to the 2x on the bottom. All right, let's go hunting for terms we can combine. This guy is x to the third e to the x. Here's an x to the third e to the x. And here's an x to the third e to the x. And we get 3 minus 9 is going to be a negative 6, plus 2 of them is going to give us a negative 4. X to the third e to the x. That's all the purple. And then we have, here, let's do this in proper order. Let's go ahead and put that second, because we have a higher degree over here with the negative 3x to the fourth e to the x. And then in back, we'll have a plus 6x squared e to the x, all over x to the 6th e to the 2x. And from there, we have, let's go ahead and take out an x squared and an e to the x, like this. You could take out a negative 2. I'm going to leave it. Doesn't really matter. But I think we get a negative 3x squared minus a 4x plus 6, right? If I take an x squared e to the x out. On the bottom we have x to the 6th e to the 2x. We can now simplify on the bottom, right? We can cancel 2 x's, or x squared I should say. We get x to the 4th, and we can cancel e to the x, which is going to give us just an e to the x on the bottom. And on top, we have negative 3x squared minus 4x plus 6, and we will leave it right there. So we are using product rule and quotient rule together on E and F. Those are involved problems. Okay, let's change gears just a little bit, still using our quotient rule and product rule. Example 2, suppose that we have two bits of given information. In purple here, we've got f of 3 is 2, and in, let's go green, is f prime of 3 is negative 5. And we will be using those in a little bit. Given the function g of x equals x squared times whatever f of x is, notice they haven't given us what f of x is, and h of x is f of x divided by x minus 1, they want us to find the equations of the tangent lines in parts A and B. So first of all, finding the equation of the tangent line for g of x. All right, well, if we go to the equation of a line in point slope form, y minus y1 is equal to m times x minus x1, we need to plug in a point and we need a slope of a tangent line. Okay. First, talking about the point, we're going to plug in 3 right there. And what goes with the 3? Well, it's a tangent line to g of x, so we need a y value on g, and we plug in 3 into g like that. Okay, and so we come up here and we say, all right, well, g of 3 is going to be 3 squared times f of 3. And that's 9 times f of 3. Gosh, if only I knew what f of 3 was. But I do, because it's in purple in the question. That's going to be 9 times 2, which is 18. Okay, so far we've got y minus 18 is equal to, I don't yet know the slope of my tangent line. I'm going to need a derivative for that. And I have x minus 3 here. Okay, so far we've just found the y value on g of x that corresponds with 3. Okay, all right. Moving on, let's find the equation of the tangent line. So what do we need for that? We need the derivative. We need g prime of x. Well, if you look back here in yellow at what g of x looks like, it's a product of x squared times f of x. So if it's a product, we need the product rule. So we're going to say the first times the derivative of the second plus the second times the derivative of the first. Okay, I'll pause there for a moment, go through it on your own, maybe pause the video and just be comfortable with what just happened. That was the product rule applied to the yellow function. Now, what do we need to find the slope way over here? Well, they want this to happen at x equals 3. The slope of the tangent line, we need to put 3 into the derivative. So we need g prime of 3 there. Okay, so pausing for a moment, in a problem like this, if you don't know where to start, focus in on the thing that you know that you've dealt with for ages, right? This in light blue, the equation of a line, right? That's what I'm doing right here. That's just the equation of a line. And then I'm figuring out all the information I need to plug into it, right? I was given an x value, I found the corresponding y value on g, and now we're finding the slope of the tangent line with the derivative. But we need it specifically at 3. So we need to find g prime of 3. Well, I'm going to plug in 3 into all of these x's, and that will give me g prime of 3. So that's 3 squared, which is 9, times f prime of 3 plus f of 3 times 2 times 3, which is 6. In purple, they told us f of 3 is 2. And in green, they told us f prime of 3 is negative 5. So that's negative 45 plus 12, which is going to give us what? A slope of negative 33? Yikes. Ugly numbers, but whatever. That's what it turned out to be. So now I know what to put in that question mark. The slope of our tangent line is negative 33. And so now we have y minus 18 equals negative 33x plus 99. And then when we add over the 18 to get slope-intercept form, we're going to get what? 117? And there is the equation of our tangent line. It's the equation of the tangent line to the yellow function, and we never knew what f of x was. We just knew two values for associated with f, right? We knew f of 3 and f prime of 3. All right, moving on. Now we get to do the same thing for h of x. So now our yellow function is over here, and you'll notice it's a quotient. So we're going to get to do all the same sorts of things, right? We're going to need, again, if I start here, y minus y1 is equal to m times x minus x1. Again, x is 3 in the question. We're now on the function h, so the y value is h of 3. And the derivative, the slope of the tangent line, I should say, is going to be the derivative of h at 3. So I need to find h of 3. So h of 3 is going to be what? Let's, here, I'll do it in kind of yellowish over here. No, I'll do it right here. H of 3 is going to be f of 3 over 3 minus 1. That's from way the heck up there. And f of 3 in purple at the top of the screen is 2. And 3 minus 1 is 2. We have a y value of 1. Okay, so we know that we're going to plug in y minus 1 is equal to, again, question mark here, x minus 3. And to fill in the question mark, we have to find h prime of x and then h prime of 3. So h prime of x is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom is just 1 all over the bottom squared. And so I just jumped into the quotient rule, right? Why? Because look at the yellow function. It's a function. It's f of x divided by another function, x minus 1. So we want f of 3, which is going to look like this quotient, but we're going to plug in 3 for all of our x's. So we have 3 minus 1, f prime of 3 minus f of 3 all over 3 minus 1 squared. And we have f of 3 in purple at the top of the screen. We have f prime of 3 in green at the top of the screen. We're going to plug all that in, and we should have our slope of our tangent line. 3 minus 1 is 2. In green up top, we have negative 5. Minus f of 3 is 2. On the bottom, we have 2 squared. Continuing on, I think that's a negative 10 minus 2 over 4. That's negative 12 over 4, which is negative 3. And that's what we put in for our question mark right there. So we have y minus 1 is equal to negative 3x plus 9. Y is equal to negative 3x plus 10. And there it is. So we had to use quotient rule on part B, and we had to use product rule on part A. All right. Example 3, last one. They want us to derive a product rule for 3 functions, f, g, and h, and then use this formula to find the derivative of, and notice we have one function multiplying another function multiplying another function. So an f and a g and an h. Okay, so first, deriving this guy. Let's just start with the derivative with respect to x of f of x times g of x times h of x. Well, let's treat this, I'm going to get rid of these colors because I want to reuse the colors here. Let's treat this, and you can do this a couple different ways, but let's treat this as my first function in green and my second function in purple. And then we'll see what happens from there. So, using the product rule, because this is the product of green times purple. So we're going to take the first function times the derivative of the second function. And to that, we're going to add the second function, I've got to figure out my colors, times the derivative of the first function. Okay, so pause for a minute and see what we've done. We have two functions, green and purple. This is green times the derivative of purple plus purple times the derivative of green. That is the product rule. But what's lurking in here, right there, is what? The derivative of the product of two functions. So that right there, which I guess we could do this in blue, right? Let's highlight it in blue, and then we'll do just this bit in blue. So we've got the first function, right? Derivative of a product is product rule times the derivative of the second plus the second function times the derivative of the first. Now I'm going to put all of that in big old parentheses and copy everything else. So I've got my green f of x equals plus, I've got my purple, where did it go? G of x, h of x. And of course, we're going to write the green part in back as f prime of x. All right. Last thing to do here is we're going to distribute this f of x. And look what we get. I'm just going to do it all in one color now. F of x times g of x times h prime of x plus f of x. I'm going to put these in alphabetical order, right? I'm doing this multiplication here right now. I'm going to put g prime of x next, and then h of x. And then in back, putting them in alphabetical order, I'm going to put f prime of x, g of x, h of x. And we've arrived at a product rule for the product of three functions. And it's kind of what you might expect, right? You have three parts to it because there are three functions. You're taking the product of two of the functions times the derivative of the other. The product of two of the functions times the derivative of the other. And the product of the remaining two functions times the derivative of the other, right? So each derivative gets represented once, and you're multiplying it times the product of the other two functions and adding them all up. So with this in mind, we want to find the derivative with respect to x of e to the x. I'm going to rewrite this as x to the 1/2 and then x squared minus 7. So if this is my first function, I'm leaving it alone. If this is my second function, I'm leaving it alone. And I'm going to take the derivative of the third function, which is 2x. Okay, so that's this bit right here that I just did. Plus, now I'm going to take my first function, f of x, and leave it alone. Then I'm going to take the derivative of this guy, right there, the derivative of g, which is going to be times 1/2 x to the negative half using the power rule. And then I'm going to take h of x and leave it alone. And then finally, we're going to take the derivative of the first function, right? Which in this case is e to the x, which derivative of e to the x is e to the x, and then copy the remaining two functions. And it may not be simplified yet, but that is the derivative of our product of three functions. I'm just going to rewrite it. Actually, let's take an e to the x out, just for kicks. And here I can add exponents, so I've got 2x to this is 2 over 2 here, so we're going to have 3/2. Over here, I'm going to write this as x squared minus 7 over 2 x to the 1/2, because we have a negative half exponent. And I took the e to the x out. And in back, we're just going to write it like this. You could distribute it, but oh, fine, I'll distribute it. X squared is the same as x to the 4 over 2. So when I multiply in the x to the 1/2, I get x to the 5 over 2 minus 7x to the half. Remember the e to the x there got factored out. So this answer is not a pretty one. There's really nothing we can combine here. I guess we could do a little bit of simplification here perhaps, but let's leave it at that. We got to where we needed to get to. So there's some work with product rule and quotient rule. Go ahead and do the remaining problems using these rules, and we'll leave it at that.